Okay, so get this. A planet with more water than Earth, but it's all trapped under ice, and it's orbiting Jupiter.
We're talking about Europa, right?
Yeah, Europa. And today we're diving deep into, well, the clues that suggest something amazing might be down there.
Life.
Exactly. Life beyond Earth. I mean, it's a question that's fascinated humans forever.
And what's really wild is we're not just talking about, like, tiny bacteria. We could be talking about entire ecosystems, totally different from anything on Earth.
It's like science fiction, but real.
Right.
So how do we even begin to figure out if something's living on a moon so far away?
Well, we've got to start with that hidden ocean.
Ah, yes, the ocean under all that ice.
Scientists are pretty sure now there's a global ocean under there, maybe even bigger than all the oceans on Earth combined.
Bigger. How much bigger?
Think up to 100 kilometers deep. Hold on, over 62 miles.
62 miles deep. That makes the deepest parts of our oceans look like puddles. How can they even tell how deep it is? It's not like we can, just go snorkeling down there.
No snorkeling allowed.
Yeah.
It's a lot of clever detective work, actually. Remember those spectrometer readings we were looking at?
Yeah, those are pretty wild.
They picked up on salts and, get this, maybe even organic compounds on the surface.
Wait, so by analyzing light, they can figure out what's in the ocean miles below the surface.
Exactly. It's like the light bouncing off the surface holds clues to what's hidden underneath.
That's incredible.
And when you combine those findings with how Europa behaves around Jupiter, well, it's pretty clear there's a huge ocean down there.
Okay, so we've got this giant hidden ocean, but what's keeping it liquid way out there by Jupiter? It's not like it's getting a tan from the sun or anything.
That's where things get even more interesting. It's all thanks to something called tidal flexing.
Tidal flexing. Okay, you're going to have to break that one down for me.
Sure. Imagine you're constantly stretching and releasing a rubber band. What happens?
It gets warm.
Exactly. That's kind of what's happening inside Europa.
So how does a rubber band relate to a moon orbiting Jupiter?
Well, as Europa orbits Jupiter, the gravity from Jupiter and its other big moons, it kind of pulls and stretches Europa's insides.
So it's like Jupiter is giving Europa a constant deep tissue massage.
In a way, yes. And that friction, that stretching, creates heat.
And that heat.
Keeps the ocean from freezing solid, even though it's so far from the sun.
Wow, that's a powerful massage. But this tidal flexing, it's not just about a warm ocean, right? There's more to it.
You're right, there's more. This constant churning, it suggests that Europa's ocean isn't just some calm, still pool of water. It's dynamic, it's active, and that has major implications for life.
Okay, so we've got this giant, possibly warm, actively churning ocean beneath the ice. But before we get too carried away, we have to address the elephant in the room, or rather, the giant radioactive planet in the room.
You're talking about Jupiter.
Jupiter, exactly. Isn't it a little dangerous to send, delicate scientific instruments that close to something with that much radiation?
It's a huge challenge, no doubt. Jupiter's magnetic field is incredibly powerful, and it traps all these charged particles from the sun.
And that's bad because...
It creates these intense radiation belts. Imagine a cosmic minefield that can fry electronics in an instant.
Yikes. Okay, not ideal for a spacecraft.
Yeah.
So how do we explore a place that could basically destroy our instruments?
That's where the brilliance of NASA's Europa Clipper mission comes in. They've designed a mission that's as daring as it is innovative.
So we're talking about sending a spacecraft to a moon that's got this crazy radiation, a thick layer of ice, and maybe even a giant ocean underneath. That's asking for trouble, right?
You'd think so, but that's what makes the Europa Clipper so impressive. It's not going to directly orbit Europa.
It's not.
Nope. Instead, it's going to slingshot around Jupiter, getting close to Europa, grabbing data, and then scooting back out before the radiation gets too bad.
So it's like a game of chicken with Jupiter.
Kind of. But while it's dodging radiation, it's also going to be busy collecting some incredible data. We're talking high-resolution cameras to map the surface.
Okay, so like Google Earth, but for Europa.
Exactly, but better. We'll also have spectrometers to study the composition of the ice, and even radar to map the ocean that's hidden beneath.
Hold on. Radar can see through ice. That's wild.
It can penetrate the surface, which means we can potentially figure out how deep that ocean goes, and maybe even what the ocean floor looks like.
This is blowing my mind. But let me ask you this. Let's say we get these amazing images back and they show, I don't know, an underwater city or something. What then?
Well, an underwater city might be a bit far-fetched, but you're hitting on a key point. The Clipper's main goal is to figure out if Europa is habitable, not necessarily define life itself. Think of it like this.
Okay, I'm listening.
We're trying to figure out if Europa is like a nice, comfortable house with running water and electricity.
And the Clipper is like the home inspector.
Exactly. We're checking for the right conditions, the right ingredients for life.
So things like what? The right chemicals in the ocean?
Yep. Things like organic molecules, certain types of salts. And remember those hydrothermal vents we talked about earlier?
Yeah, those are like little underwater volcanoes, right?
Exactly. Finding evidence of those would be huge. On Earth, hydrothermal vents support all sorts of weird and wonderful life forms, even without sunlight.
It's like a whole other world down there.
Precisely. And if we find them on Europa, it makes the possibility of life, even if it's just microbes, a whole lot more likely.
So Europa's looking pretty good so far, but what about other ocean worlds in our solar system? There's Enceladus, right? The one with those giant geysers shooting ice into space. Why not send a Clipper there?
Enceladus is definitely cool, and those geysers are amazing. But Europa has something special going for it. Its age.
Age? What do you mean?
Scientists believe that Europa's ocean is ancient, maybe even older than Earth's oceans. Enceladus, on the other hand, its ocean seems to be much younger.
So it's like comparing a brand new lake to one that's been around for millions of years.
Exactly. The older the ocean, the more time there's been for life to emerge and evolve.
So Europa has a head start.
In a way, yes.
Mm.
It's possible that life on Europa, if it exists, has had billions of years to develop, maybe even into something complex.
Okay, now I really want to know, if we're talking about potentially complex life on Europa, how do we even begin to study it? We
Yeah.
can't exactly send divers down there, can we?
Not yet, at least. And that's why the Clipper is so important. It's about laying the groundwork for future missions.
It's like we're putting together a giant puzzle and the Clipper is giving us more pieces, right?
Exactly. And even if those pieces don't scream, look, there's a fish, they're still going to be incredibly valuable.
How so?
We're talking about a much deeper understanding of Europa. Think about it. We'll know so much more about the ocean's chemistry, how deep it goes, maybe even get a glimpse of the ocean floor.
All from this little spacecraft bravely dodging radiation around Jupiter. It's amazing.
It really shows you what we can do when we put our minds to it.
Okay, but let's say, just for fun, the Clipper sends back data that's like, hey, something's definitely alive down there. Then what? We can't just stop there.
You're absolutely right. That's where things get really, really interesting. NASA is already thinking about the next step. A lander.
A lander, as in landing on Europa. But the radiation, the ice?
I know. It's a huge challenge.
Yeah.
But imagine the possibilities.
Okay, I'm imagining it. What would a lander even do?
Well, for starters, we could analyze the ice directly.
Hmm.
Right now, we're just looking at the surface. Imagine getting a sample from, say, a mile down.
We'd know so much more about the history of Europa.
Exactly. And we could look for what we call biosignatures.
Biosignatures, you mean like signs of life?
Exactly. Think about it like this. If we found even a single-celled organism in that ocean, it would change everything.
We'd know we weren't alone in the universe. It'd be huge.
Absolutely. But even if we just found evidence of life in the past, or maybe the building blocks of life, it would still be a massive discovery.
It would tell us that life could exist in places we never thought possible.
Exactly. And that's what's so exciting about all of this. It's about pushing the boundaries of what we know, about exploring the unknown.
You know, it's like we're on the edge of something truly incredible. I mean, who knows what's waiting for us out there?
That's the beauty of it, right? The universe is full of mysteries, and we're just starting to scratch the surface.
Well said. And on that note, we've reached the end of our deep dive into Europa. This tiny moon orbiting Jupiter might just hold the key to answering one of humanity's biggest questions. Are we alone? And thanks to missions like the Europa Clipper, we're getting closer to finding out. Until next time, keep looking up and never stop exploring.